Okay, so now we are going to start our new playlist, which is Kafka. And we will do, if we do hands-on, then we will do hands-on in the Python, a programming language. So basically, the playlist is the Kafka Python tutorial. So, and in this tutorial, we are going to cover a lot of topics. As an example, why do we need Kafka? Like, because we are learning the Kafka. Like, why we are like learning the Kafka? First, we need to do that. Like, what is the problem statement which Kafka is going to resolve, and what is Kafka. Then we are going to see Kafka architecture. Then we see, okay, how to install the Kafka with or without the container, maybe like a Dockerized container. Then can we see the Kafka in the UI just by clicking on the browser. Then we see the producer in the Python. Then we see the consumer. Then we see the how to produce the message in various format like JSON format, Avro format. Then we see how we can register the schema. Then we see how we can set the correlation ID for every message, which is very useful for debugging. We see the concept of consumer group. We see the schema compatibility and their testing. Like it doesn't mean just we just set the field and we say okay the schema is compatible. No, we are going to test that. We will generate the Avro schema using code as well. We will see what is partition and offset. We will see replication. And if possible, we will try all the above steps on the Confluent cloud as well, because here we are going to do locally. But if it is possible, we are going to try on the Confluent cloud as well. And maybe down the line, we will add like more and more topics like as we require, right? So first thing is that what is Kafka and why we need it. So just ignore what is Kafka, like why we are learning Kafka, what is the problem statement, where it is being used, right? So our tutorial first is why do we need Kafka? What is the problem statement which Kafka is resolved? Right. So let's see our retail sector, because Kafka is being used in many retail sectors. All right. So it is like many sectors. One is the retail sector, one is the banking sector, one is the transportation sector, many sectors. But why those sectors are using the Kafka? Why they can't just normal write the code and do their work? So why they like implemented the Kafka? So let's see before Kafka, what is happening. Right. So we have the retail sector. Retail sector means we have the Amazon.com, we have the eBay.com, we have the Flipkart.com, right? So how let's suppose there is no Kafka in the retail sector, how they are going to, because, and we know everything is now a terms of like not a monolithic, it's a microservice. So we have different microservice. All right. But how they are designed. So let's understand the current design, not the current design, the design before the Kafka. So in the retail sector, maybe like Amazon.com or Flipkart.com. So you are the user, right? So you are the user where I am moving the cursor. You are the user. You open your on your computer, you open your website, Amazon.com or Flipkart.com, right? Then you select any product and you place an order, right? So you do checkout, you place the order, right? So when you click on the place an order, all right, so some microservices, some code is going to be run at the backend, right? So there is a one service called order service. So now order is placed. Now what happens? So you just place the order, right? So order is not delivered to you, all right? So once the order is placed, what will happen next? Then order is placed, then it is going to be packed, right? So it is going to be packed, it is going to be packed in some like beautiful box, right? So how the package department is like the department who is going to pack, that is a different department, right? Who is going to receive the request. So order service send some notification to the package service. Okay, I get some details. I received this order, and now it's time to for the package service to pack that order. So package service is going to pack that order, right? All right. Now, okay, the order is packed. Now what happened? Now we need to ship to particular customer, whatever the address the customer has mentioned. Okay, I need the order at this my address. So now before shipping, we need to add some label. Okay, add some label. Okay, deliver to this address, deliver to this address. So in the shipping service, we are adding the label and we are shipping to the customer. All right. So package service, when the packet is going to be done, package service is going to inform to the shipping service. Okay, my work is done. Now you can ship the customer, like you can ship the details. So when the shipping has been started, the user might get notification. Your package arrives at this place. Your package arrived at this place. So shipping service sends some notification uh, to the user using the notification service. Right. So notification service, some email notification or SMS notification. Right. Along with that, you have observed as soon as you place the order, you get some email or you get some SMS that uh, the order has been placed. So it means the order service not only linked with the package service, order service also linked with the notification service, whose work is to send the notification either by email or either by SMS to the user. All right. So this is the current concept, right? Because we have couple of microservice. So as soon as we receive the order, there is an API called the package service, then the package service API called the shipping service called the notification service, along with the order service called some API to the notification service. So which is perfectly fine, no issue in that architecture. Even if you have to design the architecture, you are going to design in such a way, right? So user will place the order, order server will process the order. So I just write in a terms of like, but what is the problem? What is the problem with this architecture, right? Let's see the problem. Because these are the microservice, we can't say that every time the microservice maybe like we get some issue in one of the microservice. So as an example, let's suppose the package microservice has some error. So for the time being, package microservice is down, right? But still user can log into the amazon.com. Still user can place the order because the order service is up. But user has placed the order, right? User has placed the order and order service send the request to the package service, but package service is down. All right. So the package service is down, package service is not receiving the request, and order is not going to be processed. In case of microservice architecture, where the Kafka is not involved because everything is interlinked. All right. So order service is received the order, order service trying to send the request to the package service, but package service is down. So if the package service is down, package service is not going to receive the order. So if package service is not going to, the whole flow, the shipping service and then the notification service is not going to work. Because if package service is not going to do any work, then it is not going to send any notification to the shipping service. All right. So we need some kind of mechanism. All right. We need some kind of mechanism. If package service is down, then it's still like process our order, right? So what we can do is uh, let's put the package service down. What we can implement some kind of a retry mechanism, right? So retry, let's suppose order service is trying to send some call some API to the package service, and we are not getting 200 response. Then we can give a retry after maybe 2 minutes. Then again we are going to give a retry. Then again we are going to give a retry. But it is unnecessary, like so much network thing, and so much unnecessary calls. And maybe let's suppose the package service is not going to be up in 24 hours. Unnecessary, we are going to retry till 24 hours, right? So we have to give some logic, right? How many times you are going to give a retry. So that is also not feasible, right? Okay. What is the another problem? So this is one problem. When the one service is down, what is the another problem? Let's suppose none of the service is down. Let's suppose none of the service is down, but we got some business requirement. We got some business requirement. Can you introduce one more service? Can you introduce one more service? The service name is called the monitoring service, which is going to collect the logs from all the service. All right. So what you will do is you will write some code to the monitoring service, right? So monitoring service is up, right? But you need to change the code into the order service. You need to change the code in the package service. You need to change the code in the shipping service. You need to change the code in the notification service, because monitoring service is going to collect all the logs from the order service, from the package service. So what you will do is, okay, whatever the your order service logic, you will do some like logger.info, the order has been placed, right? And that is going to, that particular log is going to send to the monitoring service, right? Monitoring service. So you need to call that API monitoring service. Same with the package service, same with the shipping service. And so you could see very complex network now, because you have to change in order service, you have to change in package service, you have to change in shipping service, you have to change in notification service. There's so many just to incorporate only one service. Now assume One more service you want to incorporate, again so many changes, again so many API calls. So it is becoming very complex network just for 5 service, but in the actual work it could be 50 microservice, 60 microservice, 100 microservice, right? Just for this thing, very simple architecture, it's become very complex, right? So if the monitoring service needs to be introduced, then we have to change in like all the microservice, and along with that testing also is going to be hard, right? The development work is also hard, but the testing work also needs to be very hard, because the individual service, when you are going to do the end-to-end testing or even the unit testing, it is going to very hard. You have to mock all the services, right? So it's very hard. Okay, so what is the solution? So solution is Kafka. So that's why I said Kafka is used in the retail sector. Why it is being, because we can't just say Kafka is used in the retail sector. Why we are using the Kafka? So first we have to understand the problem statement of the retail sector. So we understand the problem statement. If this is the current architecture, if this work, then we don't need the Kafka. But we know this is not going to be work, because we can't 100% sure none of the microservice is going to be down. Right. So if one of the microservice is going to be done, our whole circuit is going to break. If one of the microservice is going to be incorporated, introduced, there will be more work from the developer, and there is more work on the tester end, and there is a more network. All right. So what is the solution? Solution is the Kafka. So just for the time being, just forget the definition of the Kafka, actual definition of the Kafka. So Kafka will help in the decoupling. Kafka will help in the decoupling. So what will the Kafka will do? So what we are going to do is, the user will remain same. User is like open his laptop or desktop and browse the amazon.com and place the order. So the order will process by the order service. Now the order will process by the order service. Now in this case, instead of directly sending the API code to the package service, like earlier what we are doing is directly sending the code to the package service. No. So now directly sending to the package service, because package service can be down, package service can be up. So that is our challenge, na? Right. So what the order service is going to do? So order service said, okay, I am not going to send the uh, I am not going to call the package service. What I am going to do is, I am just, my work is done. I am going to send some message to at some common place. So that common place is called as a Kafka. So what it will do is, order service is going to send some message to the Kafka. Kafka means, you can say, just for the Kafka is you can say kind of a folder, a kind of a messaging service, a kind of a folder. In a layman term, you can say a central repository, but it is not a data. You can consider it as a database itself, but it's not a actual database. But it's called a message service. So order service, instead of directly calling the package service and directly calling the notification service, it is going to send to the Kafka. So order service said, I don't care about the whether the package service is up, I don't care about the whether the shipping service is up, I don't care about the notification service is up or not. My work is done. I am going to send the details to the Kafka. That's it. Now but the package service has to get the details from the order service. So now, instead of directly getting the details from the order service, package service come to the Kafka or come to this message mess or center repository, you can say, and we'll check. Okay, I have the message. If there is a message, I am going to consume. So let's suppose package service is up. So order service send the message to the Kafka, and this package service is continuously going to check, maybe after every second or after every minute, going to, okay, whether do we have the message in my it there or not, right? So if there is a message, it is going to consume. Let's suppose the package service is down. In this case, our package service down, right? This is our challenge now, because the package service is up, then we can follow this architecture as well, right? But if the package service is down, and let's suppose the package service is down, so message will keep remaining in this repository, in this messaging system. Message will keep remaining in this. It is not going to wipe out. There is a time limit that we are going to cover, but just for the time being, assume the message service is not going to be go anywhere. It's not going to wipe. Order service sends a message in the Kafka, so it will remain here. So let's suppose after 1 day, after 30 minutes, after 1 hour, the developer fix the issue and deploy the package service. Now the package service is up. As soon as the package service is up, then it is going to consume the message from the center repository, and then So earlier package service is going to send the detail to the shipping service. No, because again, like because if it is again going to send the detail to the shipping service, but what if shipping service is going to down, right? So now because we have to implement the concept of the decoupling. So now the package service said I have packaged the particular product. My work is done. My work is done. So package service send the message to the Kafka. My work is done, right? Now shipping service doesn't matter whether it's down, whether it's up. If it is up, it is going to receive the message from the Kafka. Okay, whether I am going to receive the particular message. Okay, whether the package service message, package service has done his work or not. If it is done his work, it is going to check the message, whatever he required, whatever this message service is required, and it is going to receive that message. And if it is going to done, the package service send the message to the Kafka, and the message is going to be remain here. So after 1 hour, after 2 hour, maybe after 1 day, after 2 day, when the shipping service is going to be up, shipping service consume the message from this, and it's going to be up. Now, instead of directly sending the shipping service message to the notification service, no, because the notification service is down, the user is not going to get the notification, right? So shipping service, what it will do is it is going to send the details to the Kafka. It is going to send the detail to the Kafka. Kafka means a messaging system. So it is going to send the message here. So now the notification service receive the messages from the this central messaging system. All right, let's put the notification service is down. Okay, let it be down. Shipping service don't care about the notification service is down or not. Shipping service had my I have like a label that work. I have shipped that product. Now the user is getting notification or not. I don't worry. I am my work is done. I am sending the message to the because user is getting the notification that is not a work of the shipping service, right? Shipping service had that my work is done. I send the message to the Kafka. Right? When the notification service is going to be up, notification service receive the message from the Kafka, and then like process is called logic, that is send the email notification or send the SMS notification to the user. Similarly, like order service send the message to the Kafka, and notification service receive that okay the order has been like I got some kind of message from the order service. Let's send some email or let's send some SMS to the user that order has been placed. So this is the problem. This is the problem statement. This is the problem statement, and this is the solution. Okay, so now we have like covered if there is an error, but what if there is a new microservice? All right, that we have not covered. So let's suppose one microservice has been introduced. So you don't need to change the code in the order service. You don't need to change in the code in the package service. You don't need to change the code in the shipping service. You don't need to code change in the micro notification service. You just build your monitoring service and attach it with the this central repository, that is the Kafka. Attach it with that. Now order service is going to process that order service that okay my work is done. If monitoring service need the log, just take the logs from the central repository. Package service said that my work is done, I am sending the message there. If monitoring service needs some details, monitoring service can collect the details from here. Same shipping service that my work is done, I am sending the message to the Kafka. If any microservice, doesn't matter one microservice, doesn't matter 1,000 microservice, any microservice need the details, just get the details from the Kafka. I am not going to send the details to the particular individual microservice. Same for the notification service. So see, it is very easy to implement. There is a less network connectivity, because if we implement one more microservice or 100 microservice, we have to just write the logic for that microservice. We have to just attach that microservice to that Kafka. All right, you don't need to change in all the microservice, right? And now the development work is easy, testing will be easy. All right, so this is the problem statement, this is the solution. So even if you go to the official documentation, so this is the official documentation, and it is mentioned Kafka is use cases in all industry retail. So we have covered the retail. Okay, how in the retail it is going to be used, how this is one of the thing like it is going to be used, so we have covered. Okay, so they have mentioned in the banking as well it is being used. They have mentioned in the insurance, they have mentioned in the healthcare, they have mentioned in the IoT, they have mentioned the telecom. All right, so many industry. Let's cover one more example or two more example. So we have covered retail sector. All right, so Kafka is because earlier it's a tightly coupled microservice, so Kafka is used for the decoupling. Kafka used for the decoupling of the microservice. Okay, that is done. So this is the transportation sector. Just forget about this. I will like come to this one. Let's cover the banking sector first. Let's cover the banking sector. So in the banking sector, before Kafka, what is going to be happen before Kafka? Because first we understand the problem. We are not going to implement. So no. Kafka is implemented because Kafka is launched in 2011. Banking is not launched. Banking sector is not launched in 2011, right? So when there is not a Kafka thing, how the banking sector, how the retail sector is going to be work? All right. Okay, so in the banking, it is being used at many places, but one example is the fraud detection. One example is the fraud detection. So as an example, so you are the user, you go to the bank, or maybe you go to your ATM, you did some like either withdrawal or maybe using the online banking, you did some transaction. All right. So you as soon as you did some transaction, the bank receives some notification, right? Banks see some notification. So before processing your transaction, bank will check, okay, whether you are the valid user or not. Whether you are the valid user or not. If authentication is going to be failed, then you will see some error. Okay, username is invalid, or the password is invalid, or the ATM pin is invalid, right? But if the you pass all the like username is correct, password is correct, so you logged in, so you process your transaction, right? You process your transaction. So earlier what the bank is going to do is, bank is so the transaction is done, that's it, because user has to either withdraw or either has to process the transaction is done. All right. So now the transaction is done. Transaction is logged into the database. So either it could be SQL database or any database, doesn't matter. So the order service writes some details to the transaction. Okay, this transaction has been done. This transaction has been done. This transaction has been done. So there are thousand transaction has been done. So all that details has been written to the database. But whether this transaction is fraud, whether this transaction is legitimate, how we are going to know? We are not going to know. We are just process the transaction. We are going to store into the database. Now, because to check whether the transaction is fraud, to check whether transaction is not fraud, whether transaction legitimate, we have some different microservice, right? So some is a rule-based microservice, some is a machine learning concept, some is the third-party software. Like some bank maybe used all the three. So bank has implemented their machine learning algorithm. So there is a one microservice which is up and running, which is going to detect whether the transaction is fraud or not. Maybe bank has like buy some third party tool to check whether the transaction is fraud. Maybe bank has implemented some rule based means if this, if this, if that, so that is the rule based if else conditions. So bank has implemented that as well. But we are processing the transaction, we are logging into the database. Now periodically, maybe after 1 hour, we have implemented some kind of a batch algorithm. We after 1 hour, uh, we are sending a list of transaction. So let's suppose in 1 hour 1,000 transaction has been completed. So that thousand batch we are sending to the rule-based service. That thousand batch of transaction we are sending to the machine learning service. That thousand batch we are sending to the third party software. Now this software is going to be processed. Okay, it's going to check, okay, whether out of those thousand micros, out of those thousand transaction, which one is legitimate, which one is like a fraud. All right. So it is going to be checked. If it is legitimate, then no action is required because it is legitimate. But if it is fraud transaction, then it is going to send some notification to the user. It is going to send some notification to the user so that user can take some action. Maybe user can call the bank immediately. User can block his card, like like this kind of like doing. Now you could see this is not a real time. User did the transaction 1 hour ago. User is getting the notification after 1 hour. So this is not a real time, right? So fraud is happening 1 hour. Within 1 hour, it could be chances multiple frauds has been occur on their card, right? So this is not a real time. But this is the current architecture before Kafka. This is the current architecture. We are processing the transaction, we are storing into the database, we are running our batch periodically on the scheduled base. We are setting some cron expression. Okay, in the batches we are taking the data from the database, we are sending it to the all the three microservice. All the three microservice give some output, and when the output is coming, based upon that, whether the legitimate transaction, whether it's the uh, now it's visible hopefully. So whether it's like legitimate, whether it's a fraud transaction, based upon that the user is getting the SMS notification, whether and the user is getting the email notification, right? But you could see this is not a real time, right? This is generally like not good, because user is getting the notification after 1 hour. So how you are going to implement in real time? Because as soon as the user is going to do some transaction, and if it is fraud, user should immediately get the result, so that the other transaction can be prevented and user can take the action immediately. So that's why I said in the banking, in the fraud detection system, the Kafka is being used. But how? Let's see. So earlier, what we are going to do, we are first storing into the database, then we are going to send to in some batches in periodically, maybe after 30 minutes, after 1 hour, after 50 minutes, depend upon that frequency. Now user will do some transaction, and it's going to validate whether it's a valid user or not. That is fine. All right. Now, as soon as the transaction has been done, it is not going to store into the database. It is stored into the Kafka. So Kafka is going to receive that particular transaction message. Kafka is going to receive the, so now we implemented Kafka. So what is the use of this? As soon as Kafka is received that message, so now Kafka has received that message. So these three microservice, rule-based microservice, machine learning microservice, and these are the third party. These three microservice subscribe. So just forget about the subscribe thing or push thing or polling thing. We are going to cover the concept later. But you can assume that these three microservice continuously checking continuously checking the Kafka if there is any message, if there is any message, right? So these three microservices are continuously checking, continue. As soon as the message come, as soon as the transaction come, all the three microservices going to consume the message from the Kafka, all the three microservices. So let's suppose so someone access my transaction, or I did some transaction, right? So the rule-based microservice, so my transaction is going to be stored into the Kafka instead of the database earlier. It's going to store in the Kafka. So earlier we are sending we are checking this whether it's transaction fraud periodically, maybe 30 minutes, 1 hour. But now, as soon as the transaction is going to be done, these three microservices going to receive the message immediately. So as soon as these three microservices going to receive the message, they are going to process and they are going to send the result. They are going to send the result. Now, if it is legitimate, no action is required. If it is fraud, immediately the user is going to get the notification immediately. So it is a real time. Along with that, doesn't matter whether it's a fraud transaction, doesn't matter whether it's a legitimate transaction, the database should store. So now the database is going to be stored, because why we are storing the fraud transaction into the database? We have to store for our analysis purpose on the later. Okay, how many fraud transaction is coming, or how many fraud transaction we have prevented. So we have to store like all the transaction into the database. So this is the benefit of the Kafka uh, in the banking sector, and in the banking sector, in which thing, in the fraud detection. So as you could see earlier, fraud detection is not real time. Now the fraud detection is the real time. Okay, now come to the other sector. Now come to the other sector. Transportation sector. Okay, transportation sector. What happens? So in the transportation sector means like you have the Ola and Uber concept, or any taxi service app, right? So you have the taxi driver, so many taxi driver, and the taxi driver also have their like a mobile application in their hand, maybe Ola, maybe Uber, maybe any third party app, right? And you are the customer. There could be so many taxi driver, there are so many customers, right? You have the customer. So taxi driver has their like app, and customers also have their app. Customer is going to book, and taxi driver also. You could see, as soon as like you booked the you booked some cab, all right? You are going to see, okay, you are going to see in the like a Google Map kind of thing on your application. You are going to see there is a small window called a Google Map, and on that Google Map you are able to see, okay, where is the taxi driver? Okay, taxi driver is just 2 minutes far away. Taxi driver is just 1 minute far away. Taxi driver just reached. So you are going to see taxi driver actual location, actual location. So if I told you, you can implement the solution, how you are going to implement without Kafka, without Kafka, just forget about the Kafka. We are going to first understand the problem statement. Okay. So one thing is that, so okay, we see, okay, as soon as the taxi driver is running this, right? So we have the application there. As soon as the taxi driver like move, so taxi driver start moving, start moving, start moving, start moving. So this is the source, this is the destination. So taxi driver has to go from here to here to pick the customer, all right, for his ride. So taxi driver as soon as start moving, what it will do is, for every location, we have some API. It is going to get the location details of the like the user every microsecond, and it is going to store the detail into the database. All right. So let's suppose the taxi driver is here, where I have this image. So our API is going to get the details. Okay, where are you? So and store into the database. Now the taxi driver move a little bit further. Now again we are going to get details. Now where are you? What is the longitude? What is the latitude? Where are you? All right, then we are going to store into the data. Now the taxi driver is move a little bit further. Again we are going to get the details. So we are going to store into the database. As soon as the taxi driver is moving and we are storing into the database, we are immediately sending it to the customer, maybe on the event based, maybe on the event based trigger to the customer. Okay, taxi earlier taxi driver is here. Now the taxi driver reached here. Now the taxi driver is reached here. How it is going to be done? Because the location we are storing into the database, from the database customer is going to get using some APIs, right? Or some trigger or some logic. Right? But you could say this is not a real time. Along with the problem is that, so in the actual world, there is not one taxi driver, right? There is not one customer. There are thousands of taxi driver or millions of taxi driver and the billions of customer, right? So if millions of taxi driver is going to update the database at the same time and the billions of customer is going to read the database at the same time, database is going to be crash. There are huge chances that is going to be crashed, because that is the low throughput transaction per second on database. Because we are going to, because database is designed for the storage purpose. Database can't design for the high throughput means database can't handle so many like insert operation in a microseconds gap. Database can't database is not designed designed for this purpose. Basically it doesn't matter whatever the database you are going to use. All right. So maybe if you said, okay, no, I am going to implement this kind of database, this has more throughput. Yes, that could be more throughput, but if we are going to increase more and more, then there are huge chances the database is going to be crash. Or if the database is not going to be crash, your application is going to be slow. Your application is going to be slow. So low throughput is the problem. Transaction per second on database problems. Where frequent update like driver location update in a taxi service app are required. If the database is overloaded with the right request, it can slow down the read request and affect the user experience. If database is not designed to handle such high throughput, it can become a bottleneck and degrade your performance. So this is our actual applications. So what is the like how we are going to, along with that, you could say this is not a real time, because first we are getting the details, we are storing into the database, and then we are running some API, and then the customer is getting that data. So, and by then customer is getting the detail, driver already moved. So this is not a real time, right? Because to store and then to read, to insert and then read, it will take some second, right? Or maybe some 2 second, maybe 3 second, depend upon the load. All right. So this is not a real time, because by then driver already moved here, and the customer is seeing the location, driver is here, but the driver is actually here. So this is also not real time. All right. So customer may not see the real time location because there should be some delay along with the bottleneck. Bottleneck I already told, because if you do so many insert and so many read operation and at a microseconds gap, so it will be a bottleneck on the database. Okay, how you are going to solve this problem? Because this is a transportation sector. So the solution is Kafka. Solution is Kafka. So now earlier, so driver taxi said, okay, I am sending the location to the Kafka. So Kafka means you can say the central messaging system. So Kafka is designed for the high throughput. Kafka is designed for the high throughput. High throughput means Doesn't matter, you can send millions, billions of transactions, Kafka can handle, but database can't handle millions and billions transactions per second. So database can't handle, but Kafka can handle. So we have solved this problem. We have solved this problem, that the low throughput on database. We have solved this problem by introducing Kafka, because Kafka is high throughput. So now doesn't matter whether you have 1,000 taxi driver or million taxi driver, and maybe like 100K taxi driver are going to send the details at the same time. Kafka said, okay, I am ready to receive the messages. So send the details. As soon as the details has been sent here, and the customer can receive the details directly from the Kafka instead of the database. But still, that in the database we are going to store the details. Still, now we are going to store the detail based upon our capacity. So we are going to store the why we are storing into the data in the database. The reason is for the analytic purpose on the later side, down the line. Analytics means maybe we're going to know, okay, so driver go from this location to this location in how much time, is there any accident, and like what happens. So all kind of details, or all kind of analytics doing at a later stage. So that's why we are going to store into the database. Otherwise otherwise if we just think, okay, if we don't want to do the any kind of analytics, then we don't even need to do any kind of a database concept. We can just say, okay, when you move, send the location, and then customer will get the location. So this is a real time. As soon as it move, it will get the location. As soon as it move, it will get the location. As soon as it move, it will get the location. All right, so we have solved. The more specific diagram we can see like this. So user is there, user is going to book a ride. As soon as the user is going to book a ride, so here we are going to cover that some kind of a location thing, some kind of a location thing, how the user is going to know where is the driver. But in actual the concept is little bit different. So user is going to book a ride. As soon as the user is going to book a ride, user is not going to so book a ride is not going to write the detail to the database, because if it is going to write the detail to the database and the driver is going to read from the database, then again the concept of the low throughput, again there is a bottleneck. Because right, because let's suppose 500,000 customer is going to book a ride at the same time. Right. So now book a service microservice is going to do 1,000 operation on the database. So maybe database do some late operation, and if there is a delay, then the driver is going to get the notification and delay. All right, at later time basically, because user book they write at 11:20, but the driver is getting the notification at 11:25, because driver has to read from the database. So that's why, so instead of user when book the ride, so booking service receive the message and it write the data to the Kafka. As soon as it writes detail to the Kafka, driver is going to get the details from this. So driver is going to get the details. If the driver confirm the ride, driver is not going to write it to the database. Driver can write to the Kafka only, and user will get the notification. User will get the notification via email or via SMS. Your cab has been booked. Your cab has been booked. But everything, whether the ride has been booked, whether the driver has confirmed where is the location, everything we are going to store in the database for the analytics purpose. All right. So that's why we need Kafka. So we have covered one thing. Why do we need Kafka? What is the problem statement, right? Because to actually jump into the Kafka, now what is a producer and consumer, we should know here why we are learning this Kafka. Why can't I learn some another technology, right? So why I am learning this Kafka? So you should know Kafka is like very important concept, and I, we can't say justice is a very important concept, but where, in which industry? Because you say, no, 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 I am working in the banking sector. In where I am going to implement this Kafka? Because you said you give me the example of the retail sector, but I'm not working in the retail sector. I'm working in the banking sector. Then why should I learn Kafka? So that's why I give you all the example, because Kafka is being used in all the sector for different purposes. So so let's come to the official documentation. So Kafka use case by industry. Kafka is used in the banking sector. So in the banking sector, so you could see Apache Kafka for the real-time fraud detection, but it could be like many other things. So many bank like Nationwide Bank, Capital One Bank, Robinhood Bank, and other banking service use Kafka for the real-time detection, cyber security, some regulatory compliance, they are used. In the retail sector, retail means like Walmart, Domino's, Amazon, Flipkart, in the supply chain. All right. And insurance sector, Morgan Stanley, JP Morgan Bank, Credit Suisse, Bank of America, all these also using this Kafka for the real-time monitoring, for the real-time predicting. In the healthcare industry, sorry, in the IoT devices, in the telecom sector, and in the transportation sector. So in all the sector, like we are using that. All right. So now we see what is the problem statement. Now let's see. Let me scroll down. So what is basically Kafka? So if I click on it, the official definition, what is Apache Kafka? This had developed as a public subscriber model to develop by the LinkedIn, and it's an open source, distributed, is it event streaming? It is so many terminology it is being used. Just forget about all this terminology. But by looking above problem statement and above solution, what we can say, what is Apache Kafka? Kafka is a publish subscribe messaging system to handle mass amount of data. Publish subscribe means some microservice is going to publish the data, some microservice is going to consume the data. So consume means you can say subscribe kind of thing basically, but the terms is different. We are going to cover at later stage, right? And it is a messaging system because it's going to store all the messages. So we can say Kafka is a publish subscribe message system to handle mass amount of data. Along with that, we can say it is an event streaming platform. Because why it is event streaming platform? What is event streaming platform? Continuous and real-time flow of event between message system. Because if you see fraud detection, it is a real time. As soon as like a transaction has been done, immediately all the three microservices going to consume the message immediately. So this is the event. As soon as the message come, immediately the fraud has been detected. So we can say it is a event streaming. And if you don't want to use this event streaming keyword, you can say continuous and real-time flow of events means a kind of a messages between different system and application, or different system, this system and this application, right? So we can say this is a Kafka. So that's it. That's the end of the video. So in the next video, we are going to cover the basic architecture. Basic architecture. We are not going to cover the complex architecture. Complex architecture we are going to cover maybe down the line, but we are going to see the basic architecture because till now we have not even covered what is Kafka in full, because we have covered what is Kafka, but a very few lines. All right. Okay. We know. Okay. Kafka is some kind of a messaging system which is going to handle large amount of data. Along with that, we covered Kafka is a like real-time flow events messaging system between the different applications, right? But it could be many more. We are going to like look at that. So that's it. That then end the end of the video. And thank you.